We start our lecture. I'm starting the data analysis series. So initially, as we know, there are several data analysis techniques, and there are two types of data. One is primary data, and second one is secondary data. And both data types are having their own tools and techniques. So today, I will be dealing with the uh, panel data and secondary data and panel data. The nature of what is panel data, as we know, that is mixture of cross-sectional and time series. If we see this file, here is time series, and we have about 11 years starting from 2012 2022, and there are firms, different firms are there. So we have almost 58 firms, and the time period is 11 years. So that is the mixture of time series and cross sectional, so we can name it the panel data. So it depends on your objective of research, your nature of research, what kind of variables you are having. So then you can first of all, what is the first step? The first step is we need to organize our Excel sheet. What is way to organize and manage the Excel sheet? So we have multiple columns. First column is related to the name of firms. So name of firms, here we have 58 firms. So second column we have the ID, then we need to provide them ID number. So firm 1 is 111, firm 2 will be having ID 2, firm 3 is having ID 3, up to 58. And firm 1 data, we have 11 years data for firm 1, for firm 2 11 years data. So our data time period in this sample is in this study is 11 years, starting from 2012 to 2022. So in this case, the dependent variable is profitability, which is measured by return on equity and return on asset of firm, and independent variable is CO2 emission, environmental quality, that is CO2 emission. And we have few set of control variables, firm specific variables like leverage, firm size, firm age. These are the control variables. So I suggest you how you have to place the variables, what will be the order of your columns in the Excel sheet. So first one is the name of firms, then we provide the ID, we give the ID, then we have year. Then first of all we need to provide the dependent variable, then I suggest you can have the independent variable, then control variables. So same sequence, if you have same sequence, if you manage this sequence in Excel file, then your tables, the tables which you will be generating will be having the same sequence. So the Excel file is important if there are if it's unbalanced panel data, because we have few missing values. If we are having missing values, just place 0. If we are not placing 0, then Stata will have may have problem. So Stata only accepts the numerical values. So if there are some alphabetic or some special signs, so Stata will not work. So this is a full sample. There might be multi countries, there might be one country. In this example, we took the data of different firms, data of different firms, 58 firms of two countries. One is Morocco, second one is Tunisia. So here are the firms of Morocco. We have the data of Moroccan firms, 29 firms from Morocco, and 29 from Tunisian firms. So we have these firms. Then in full sample we have merged them. That is the full sample. First we have five full Moroccan firms. Then we placed the Tunisian firm. So the sum up is 58 firms. If you look at ID, that is 58 firms, and we have the same variables: profitability, environmental quality. Then we have set of control variables. So once your data sheet is ready, then you have to work in the Stata. So what is first step? I have this Stata software which is portable. So here is the Stata software. So in Stata software, let me open it. So here what I need to open, we can open that SM Stata 64. I just need to double click on this Stata software, and what I this is working now. It's ready for inserting data from Excel sheet to Stata. So there are several ways to insert data from Excel sheet to Stata. So uh, the most easiest way and most I think is the most easiest way. What is command? I will just write edit. If I write edit and enter, so I'm having new phase. What is new phase? This is Excel phase. And what we need to deal with this phase, we have to take the data from Excel sheet and we can place here in Stata. So we need to insert data from Excel sheet to Stata. There are several how you can say ways, but the most easiest and way is this one. So I have the Excel file. These are the variables, and there are number of forms, and this is complete file as I have explained before. What we need to do, just click on the first box, then you need to press Ctrl Shift together, and here you have to right click. So once you will be going to right click, it will select the all columns which we are going to use in our research, in our analysis. So what is command? Control Shift right arrow, then you have to press down arrow, then all lines, all forms will be selected. So with this command, your only data will be selected which you are going to operate in your analysis, which you are going to use in analysis. So once it's selected, you have to copy it. What is command of copy? So we Control C, data is copied. Then go to the Excel, go to the Stata, the Excel form window. Here you have the first box. Just Control V. So once you paste the data with command Control V, we are having this phase. What we need to do? We need to do just variable names. So here is the data layout. So if you are having any non-numeric number or anything, any non-numeric number or any special sign or alphabetic, that series will be highlighted red. So what does it mean if it's highlighted red? So that series will not give you the results. You will be unable to operate the results. So this is the best way to insert data from Excel to Stata. What it tells that our data is not having problem. So if we look at first column, these are non-numeric, these are the name of forms, so it's non-numeric. If it's non-numeric, so that's why it's highlighted. So in this case, so none of the value is highlighted, means their data is okay. Now our file data is inserted from Excel to Stata. Now we are ready to analyze. As I stated earlier, we are dealing with panel data. So we are dealing with panel data. So first of all, we need to generate panel. First, what we need to do, we need to generate panel. So here I have commands. I will upload these commands in the description. So these commands will help you. So these are the commands file. So first, what I need to do? First I need to do we have to generate panel. So we have to generate panel. What is command? You can just copy it or you can memorize it. What is command? xtset space it space. Yeah. So I just copied and I went to the I have here is the command bar. So in command bar we just copy and paste and enter. So how we'll be able to know that our data panel is generated after giving the command, once we put command here, once we write command here and we enter. If this is not if we are not getting anything red here, so it means our command is working, so there is nothing wrong. If it's showing something red message, so it means it's not working. So our data as panel is generated. As we know, this is for the students who are working on panel data first time. This video will help them. So normally we cover descriptive statistics, we cover the correlation. Descriptive stat tells us the summary of overall data and how our data is behaving. Is there any outlier, what mean values we are getting, what is the minimum value, maximum value, what is the variation in data. Then we can check the normality of data by using descriptive statistics. Then we have the correlation analysis. What does correlation deal? Correlation is the association between variables, and it also tells us the overall problem of high association, problem of strong association between the variables, means multicollinearity. And it also tells us the how the variables having the relationship to each other, means positive relation, negative relation, so weak association, strong association. After correlation, we need to check the multicollinearity diagnostic test, which is can be determined by various inflating factors and tolerance. So we can generate VIF. Then we have the static panel and dynamic panel for hypothesis testing. So it means that is regression. So we have the static panel that is covered by fixed effect model or random effect model. We need to select one of these models. So based on the Hausman test, after that we deal with the dynamic panel. This is more superior technique to deal with panel data. If that we name it generalized method of movement, and here that technique also deals with the endogeneity problem and autocorrelation issues. So we will be having 4 types of analysis: descriptive stat, correlation, multicollinearity diagnostic test, and hypothesis testing through static panel and dynamic panel. This is the outline of today's lecture. So our data is ready for analysis. We have transformed data from Excel sheet to Stata, then we have generated panel. What is first test? That is descriptive stat. What is the first test? That is descriptive stat. And what is command of descriptive stat? It's the command is very simple: summarize. So we can here we have the command file. So here what we need to write the command, that is summarize. Just copy and paste in the command bar. Here is command bar, I copied, and here I am going to paste. So we had the descriptive stat here. So then what is next? Next is we have to copy, we have to shift these results from Stata to Excel file. I have just copied the data which the results which I am required, which we are required for our analysis, for our study. Just I copied, selected. Then after selecting, we need to right click. After right click, we select copy table. What we do? We need to select copy table. After selecting the copy table, we move to the Excel file. Here we have the Excel file. Here we can generate new sheet, and we can rename it results. We can rename it results. So here are the results. So what is the name of first results? Is descriptive stat. It's descriptive. So here the results of descriptive. So I have copied, just select it. After selecting, right click, then copy table. So here I need to place these results. So right click, then we have to select paste special. So once you click paste special, we need to select text. what we need to select? Text. So text and OK. So here once you will be placing results, once you will be shifting results from Stata output window, Stata to Excel, so we should be very careful. Sometimes data Stata mix these columns and rows, so we should be vigilant. We need to match. So here the values and the data are under the same column. Okay, so then what we can do, we need to delete the blank rows. We need to delete farm name. We are not supposed to have ID. We are not supposed to have years in our panel results. We just selected them and we need to delete them. So there should be no blank row. Okay, we have to delete it. Okay, then you can manage its formatting, what font size you are looking for. So for example, if I am looking for 12 and the font type is Times Roman, for example, so this is selected. So even I can if I want to have border all sides, so I placed border. So then these results are ready to shift in the Word file. Then you can move these results into Word file. So what we did, we had just done with the descriptive stat. Later, what is the next step? Next step is of analysis is the correlation. What is the next step of our analysis is we need to deal with correlation. And what is command of correlation? Here is the command of correlation, very simple command, PWCORR. You can even type or you can even copy and paste here. I have copied and pasted, then I put enter. So these are the results of correlation. What we need to do, just as I've explained, just copy the column. Okay, so then you need to place them. I have just copied this copy as table, then I have the Excel file. So what about these results are correlation. So I can place here. So once we are going to paste here, we have to select paste special, and here is the text. We need to select text and OK. Here there are chances you might be getting. So this is we don't need ID, we don't need here, we don't need this. So we should be very careful while looking at the columns. Okay, so you can match the results from Stata. So each, we are not supposed to have ID, we are not supposed to have here in the Excel file. You can delete them. So we need to keep ROA, ROE, ROA, CO2 median, leverage, from size, from age. Okay, so you have to organize your this correlation table, but you should be very vigilant. So you are not supposed to delete the important column. Okay, but first you have to you need to be very careful that there is proper every value, specific value is placed in the specific column. Okay students, then we have the next text is about variance inflating factor. Variance inflating factor. So for variance inflating factor means multicollinearity diagnostic, first we need to run the regression. So what is command? Very simple command, it's reg space. So as you remember, I explained that first we have to put the dependent variable in our Excel file. You see, firm name, ID, year, dependent variable. We have two proxies of dependent variable. One is ROE, second one is ROA. Then we have independent variable, which is CO2 emission. The other variable is leverage. Next is firm size, firm growth. So I am dealing with to calculate the variance inflating factor, means multicollinearity. I need to run the regression, then I can calculate the VIF. So first I will the variable which you will be shifting, which you will be selecting, that will be considered as a dependent variable by the software, by the Stata. So I have selected ROE, which is dependent variable. You better know which one is your dependent variable. Software doesn't know what variable you will be placing first time. It will be considered as a dependent variable. I have selected ROE, and here is small arrow sign. Just click on small arrow. If we click on small arrow, look at the command bar. Reg I wrote, then I put space, then re is placed, shifted from the variable view. Then I need to I am going to run regression. So once we are going to run regression, we put only one dependent variable, one proxy of dependent variable, not all proxies at same time. So one by one, first model with ROA, second model with ROA. Then if you have more than one proxy, you can run multiple models. So our dependent variable is ROE and ROA the moment I am dealing with ROE. So ROE is moved here. Then I need to select independent variable, which is CO2 omission. I just clicked on the arrow sign. Then we have leverage, means control variable, from size, from age. These are the variables. All variables are moved in the bar, means command bar. So I repeat, the first variable, whatever the variable you are moving here, that will be considered as a dependent variable. So you should be very careful. So after placing in the command bar, we have to just click on the enter. So we are getting the regression results, but our data is panel data. We are dealing with the panel analysis. And then why we run the regression? We run the regression to calculate the variance inflating factor, VIF. So we have run the regression, then we need to calculate VIF. VIF is a measure of multicollinearity. So simply VIF, what we need to write? Simply VIF. I wrote VIF in the command bar, just enter. So here we are getting the VIF. Just copy this table and place in the Excel file. So what is the name of test? The name of test is VIF. So we can write the name, name here. What is name? VIF means variance inflating factor, which is test of multicollinearity. So what we need to copy? So we need to copy as copy table. After selecting, just copy table, then go to the Excel file, then right click here. After right click, we need to paste special. Once paste special, we need to select text and OK. Then here you can change its formatting and whatever you want. You want to put border shader, I suppose. For example, if I am dealing with 12 Times New Roman and the style is Times New Roman, and I want to have border and shader in all rows and columns, it's up to you. Then you can move in Word file and you can refresh by yourself whatever you want. So this is we have done with 3 tests: descriptive, correlation, and multicollinearity. Now we left with hypothesis testing. For hypothesis testing, we normally deal with static panel and dynamic panel. So in static panel, we have 2 types of tests. One is fixed effect results. The other one is random effect, fixed effect and random effect. First we need to run the fixed effect as well as random effect. Then we need to select, either we need to go for fixed or we need to go for random. For the selection of appropriate text, we have a Hausman test. Hausman test normally deals with the selection of fixed effect or random effect. So we have command of fixed effect, we have command of random effect. So if you look at 6, what 6 deals with? This is static panel. So we have the command of fixed effect. Well, it's a very simple command, xt regression. Then dependent variable will be moving from Stata window. Independent we have, as well as we have the CV as the control variables, comma, then fixed effect. just copy this command, okay, and we can place in our Stata file. Here we have placed the command, but we need to put the dependent independent variable here. So what is dependent variable? The moment we are considering ROE, okay, ROE, I just selected and click on the arrow sign. I am not dealing with ROA at this time, okay. So then CO2 emission is your independent variable, then control variables, leverage, from size, from age, all variables are moved. Here you see, last control variable, and there shouldn't be no space. If you put space, it will give you error. Then move your cursor at the end, fixed effect. What we are doing now, we are extracting the results of fixed effect. So this is command xtrg space dependent variable space independent variable space control variables comma, then fe means fixed effect. Just enter it. Just enter it. So these are the results of fixed effect. But the moment fixed effect, we are not sure, either we need to deal with fixed effect, either we need to deal with random effect, and Hausman test will help us to identify whether we go for the fixed effect or whether we go for the random effect. So we have done with the fixed effect. Now we left with the random effect. We have same variables, we have same command, just I have copied the command above, and what I need to change here, I need to change RE. RE means random effect. RE means random effect. So here is the XT regression, then we have space ROE, CO2 emission is the independent variable, then control variable, comma, and RE means random effect. So once we click enter, so we are getting the result of fixed effect and random effect, but we are not sure which result we have to rely. So we have another test, that is Hausman test. Hausman test chi-square value will suggest us either we have to rely on fixed effect or random effect. So for before applying the Hausman test, we need to store the results of fixed effect and we need to store the results of random effect. We have the command here. What is command to store the result of fixed effect? What is the command? Estimate store fix. Just copy this command and paste here and enter. We are getting this message, so it means it's working. So results of fixed effects are stored. Same command is for the random effect. Just be careful while selecting the command and putting the name. These should be the same alphabetic, these should be same uppercase or lowercase. If any of the alphabetic or space of you are facing putting more spaces, more than one spaces, you are not putting space, you will be unable to generate results. I just copied and I placed here. Now enter. Now results of fixed effect and random effect are stored. Why we store them? Because for to get the results, to select the fixed or random effect, so we must have we must have to run we must have to run the Hausman test, and Hausman test will differentiate either we have to go for random effect or fixed effect. So here we have the command of Hausman test, very simple. We need to write just Hausman and space fix space random. Command is here, just copy and we can paste in the command bar, just enter. This is the result of Hausman test. We only consider this value. What does it mean? This value is the chi-square value and its p value is significant, means it's less than 5%, means 0.05. If it's significant, if it's less than 5%, means 0.05. So what value we obtain? We got 0.000, means it's less than 5%. It means it's significant. So here is decision. Why we apply Hausman? to select fixed or random. So here we have decision. If chi-square p-value is significant, means 0.00, it's significant, we prefer fixed effect. We will consider the fixed effect results. If this value is insignificant, then we prefer the random effect. So already we have stored the result of fixed effect, we have stored the result of random effect. Here are the results of fixed effect. So we just copy the table, this part of the table, okay, and we have just copied these, what we are required only this part copied, and we can place these results here. So what we applied? Fixed effect. What we applied? Fixed effect. So we write here, and just you need to place the results. So for copy, I selected right click, copy as table, then go to Excel sheet. Here you need to right click, paste special text, and you will be getting the values. Again I repeat, we should be careful. So values should be under the same column. So first one is coefficient. Standard error column is this one. This is t-stat value. This column is dealing with t-stat. This column is p-stat. These are the 95% confidence level. You need to match which values relate to what expression. Okay, so coefficient, standard error, t value, p value, 95% confidence level, and interval. So once you place in Excel file, you should be careful. So this is the coefficient, this is standard error, this is t value, this is p value, this is 95% confidence level, this is interval. Okay, so we just need to be very careful. Even you can write manually here and you can match. So we need to delete the extra rows and extra column, I think. Then you can put you can change their font size, you can change their font type, it's up to you. Okay, then here you can place the border shader, it's up to you. So but be careful, it's coefficient, it's standard error, it's t value, it's p value, these are the 95% confidence, and it's interval. So we have to place the results here, and we have to add few lines here. One is the f-stat, f value, then we need to add p value, p value, then we need to add Hausman chi-square, Hausman chi-square value. Okay, so here, so what we need to write, so we need to write the f-stat. So f-stat value, just go to the Stata results. Here is f-stat, its value 1.28, 1.28. Simply go to Excel file, 1.228. So what does f-stat tells us? F-stat leads that model, either model is significant or not significant. Model is significant or not significant. So its p value is a decision criteria. We can look at the p value. As I told you, p value should be significant. P value should be significant means less than 5%, means 0.05. Then we say that there is a significant impact of your model is significant. So these are different, there are different assumptions of f-stat, t-stat, and p value. So I will be not go in detail for this assumption, but once I will be having the lectures on econometrics, I will explain in detail how we calculate p value, how we calculate f-stat, how we can calculate p value, what does it mean, what are their criteria, so what are their assumption, what normally they explain, so what are their hypothesis, what's the null hypothesis of f-stat, what's the null hypothesis of t-stat, and everything we will explain. But here, what is the decision? The decision, I will discuss the decision. If p value of stat is significant, what is significance level? 0 point less than 5% means 0.05, then we can say model is significant, otherwise there are problems. Then we need to report the R-square results. These, if model is insignificant and very few variables are significant, obviously we will be getting very low, means R-square value will be very low. It's 0.0089. It's very low. So you can report the values of R-square. You can report the value of chi-square. You can report the value of p-value of chi-square. What is p-value of chi-square? Sorry, p-value of f-stat 0.278, 0.278. I have just rounded the last digit, and here we have the, even we can write the r-square. We can write the r-square. What is r-square? 0.008 something. And chi-square value, what is this chi-square value? If you look at the Hausman test, this is Hausman test chi-square value 0.00, 0.00. We need to report 0.00 something, so we are getting the values. Okay, this is about your static panel. What variable we used as a dependent? ROE. Then we left with GMM. So that is normally called generalized method of moments. So that is more advanced, and it resolves the problem of why our variables are insignificant, model is insignificant. So it means there are some OLS assumption problem, there might be the problem of autocorrelation, there might be the problem of multicollinearity, there might be the problem of heteroscedasticity, and different problem can be there. So I forget, I skipped to explain the result of VAF. VAF is the measure of multicollinearity. So what does it tells? What is the decision criteria? If the value of VAF value is less than 5, it means our model is not facing any problem of multicollinearity. It means there is no issue of multicollinearity. We can move with all independent and control variables in our model. So if we look at these values, all values are less than 5, so it means we can move with these all variables which we have selected in our study. Okay, so multicollinearity cutoff point is, rule of thumb is, threshold value is less than 5. So now I move towards the static panel. After static panel, we move towards the dynamic panel, and dynamic panel, that is the GMM approach. So for dynamic panel, we have command, and here we can just copy the command. Here are the dynamic panel commands. So just copy this command, xtdpdsys system dynamic panel. We are using applying the system dynamic panel approach. DB means dependent variable, IVs mean independent, then control variables, lag2, then this is the command, first step dynamic panel, two-step dynamic panel. We are using two-step dynamic panel. Just copied this command and we have placed in the command bar, and we need to place the name of dependent, independent and control variable here. What is dependent which we are targeting? ROE. ROE is moved here, then we need to move, we are not supposed to move ROA. For ROA we need to run again static panel and dynamic panel. CO2 emission is control variable. We have moved CO2 emission, we have moved leverage, we have moved firm size, and we have shifted the firm's overall age. So here we need to, here if you see there is a space between firm age and comma. There shouldn't be no space here. You should be careful. There shouldn't be no space between the last control variable and comma. Then you have to put your cursor at the end and press enter. These are the results of static panel. So just copy these results. So what is command? Select them, right click, copy table, go to Excel. Then here we need to select right click, paste special, text, and OK. And again we need to delete the extra columns, extra rows, but very careful, as I explained before. This is coefficient. We are not supposed to keep these these rows. We can delete them. First one is the coefficient. This is coefficient. This is standard error. This is t-stat. This is p-value. This is coefficient, 95% confidence level, and here is the interval. Just delete the first line and upper line and just write manually. Then it will help you, and you have to be careful while moving. You have to be careful while once you are dealing with the pasting data from Stata to Excel file. So here what we learn from these results. So if we look at here, if we look at p-value is significant. L1, what is L1? This is lag 1 of dependent variable. What is dependent variable? ROE. Lag 2 means second previous value of ROE. So these are the two-step dynamic panel commands. Then we have a dependent variable, CO2 emission, and control variables. Look at p-value. P-value is the decision criteria of significant or insignificant. If p-value is less than 5%, means 0.05, variable is significant. Okay, individual parameter is significant, and here we report only two things. What is our concern? One is the impact of independent and control variable on dependent variable. In this case, our dependent variable is ROE, so, and independent variable is CO2 emission. So coefficient is suggesting us the magnitude of impact and its direction. If negative sign, it means it's having it's having inverse relationship, inverse impact, negative effect. Okay, so CO2 emission is negatively impacting the return on equity, and now we need to check either it's significant or insignificant. Two things: coefficient is suggesting us the magnitude and direction of relationship, direction of effect, negative. So then p-value confirms it's significant or not. If it's less than means 0.05, then we can say it's significant. We normally use 10% significance level, we can use 5%, we can use 1%, but in this case we are using 5% significance level, so value should be less than 5%, means 0.05. so then we can say it's significant. So all the variables are significantly affecting the return on equity. So these are the results of GMM dynamic panel, and we have moved these results here. But what we need to do, we have to check the instrument of GMM. So instrument of GMM, we can check the instrument of GMM through Sargan test. We can apply the Sargan test, and what's the Sargan test command is, simply we can write the Sargan. We can write Sargan test in the command. Just go to the command bar where in Stata. So we have command here in this file. What we need to write? State Sargan. So here is the Sargan test. Just we entered. So chi-square of Sargan should be insignificant, then we can say our instruments are valid. What I need to write in here, we can generate new column. What we name it? Sargan value. So its value is, Sargan value is, so okay, its value is given here. Go to the Stata, 53.609, and p-value is insignificant. Sargan should be insignificant, then we can say our instruments are valid, which we used in this model. 53.609, 53.609. Then we need to apply the autocorrelation test, means bonds test. So here we have command of state A bond, state A bond, just copy it and place in the command bar and enter. We have the values of AR1 and AR2. So AR1 should be significant, AR2 should be insignificant. So 1 is dealing with AR1, so we can move here. This is AR1, then we can add one more row, AR2. So what is AR1 value? What is AR1 value from this result is 0.2301. So 0.230, 0.230. So what is the AR2 value? The value of AR2 is 0.1629, 0.163. We can round up the third value, 0.163. So AR1 should be significant and AR2 should be insignificant, but in this case its AR1 is insignificant. It means this model is facing the problem of autocorrelation. So then we need to check the diagnostic test, either first order of autocorrelation, second order of autocorrelation. That is the assignment of advanced econometrics or econometrics. So we have done with descriptive stat, we have done with correlation, we have checked the variance inflating factor. Later we have tested the hypothesis through static panel and dynamic panel with the variable which is a dependent variable, which is ROE. Again we can run our analysis with ROA because we have another dependent variable. So if we have multiple dependent variable, multiple process, we have to run model multiple times. So now we can run the model with ROA. So we have done already, we have calculated the descriptive stat, we have calculated the correlation, and we have already checked the VIF and tolerance. So we are not supposed to repeat the same with ROA. What we need to repeat, we need to check with the ROA the impact of independent and control variable on ROA, means second dependent variable. So we need to just apply the static panel and dynamic panel. We have commands of static panel. So what is command of static panel? Xt, just copy this command. Static panel, we have fixed effect, we have random effect. So for fixed effect, so I just copied the command of fixed effect, then I deleted here the dv, iv's and cv's just to move the dependent variable. What we are considering dependent variable? ROA. So we moved ROA here, then we moved the independent variable CO2 emission, then control variables from size, from age. Then what we need to do, we should be careful, there should be no space between control variable and comma. So I have moved the space and I moved the cursor at the end and just click on enter. So our fixed effect results are we obtain the fixed effect results, but we are not sure. As we know, fixed effect, we run the fixed effect, we run the random effect, then we need to select either fixed or random. For the selection of fixed or random, so we have to apply the Hausman test. Hausman test chi-square p-value is the decision criteria. What is decision criteria? If chi-square p-value is significant, then we can say we have to select the fixed effect. If it's insignificant, then we can go for the random effect results. So same command we can apply here. Just copy this one, and we need to change ROE. But be careful, there should be no space at start. There should be no space at start. So I need to change with FE with RE. FE with RE. So RE means random. So results of random are also generated. But again, we can't rely either. We need to select fixed effect or random. For this, we have to run the Hausman test. For running the Hausman test, we need to store the results of fixed effect and random. So we better know the command of how to store estimate store estimate space store space fixed. Just copy it, paste here, then enter results of fixed effects are stored. Then we need to store the results of random effect. Just copy, okay, as we did before, and place in the command bar and enter. So results of random effect are also, we have saved the result of random effect. So then we need to apply the Hausman test. Here we have the Hausman test. So what is Hausman test? So it's just here is the command, and here we can access the results of Hausman test. Just place the command and enter. So what is decision criteria? Chi-square p-value, it's significant. It's significant, 0.00. Once it's significant, we prefer the results of fixed effect. So here are the results of fixed effect. You need to copy these results, copy as a table, then you can place, and then you can add xstat, then you can add R square. You see here results are somewhat extent better than the ROE results. Here xstat p-value is significant. The overall model is significant. R square is better. So there was 0.00. So here is 3% R square because we have only few variables. Return on asset means profitability of firm is depending on lot of variables, many variables, but we selected only 3 to 4 variables. It means our model is facing omitted variable problem. So there might be we have ignored some important variable. That's why R square value is very less. So R square normally tells us the power of our explanatory variable towards the dependent variable. So its limit is 0 to 1. 0 to 1. More value near to 1 is the more explanatory power of independent and control variable, and if it's less near to 0, it means weak power of. But overall model is significant. Few of the individual variables are significant. And how to place the results in Excel file, I have already explained. Here is the sample of Excel file. So here you can place your results in the Excel file, but you need to add f value, you need to add p value of f stat, then Hausman chi-square value, then R square value. You need to add these values manually in Excel file. Then we left with the dynamic panel with ROA. So same command, we have command here, dynamic panel. Here we have command, just copy, and we placed this command in command bar of Stata. Then we need to place dependent and independent variable. Here dv, iv's, we need to remove them, and here our dependent variable in this case is ROA. We just click, then CO2 emission is independent, leverage from size, from age, they are moved. Look at here, we need to delete this space before comma, then shift your cursor at the end and enter. These are the results of GMM, and we are getting the better results, and coefficients are better, and their signs you can check. Then we have to apply the Sorgen test to check the instruments, either the instruments are valid or not. Then here is the command state Sorgen, just place in the command bar, enter. We are getting the chi-square, Sorgen chi-square. So it should be insignificant, and it means our instruments are valid. Then we need to check the autocorrelation problem. For autocorrelation, what is command? State abont. So here just copy the command, go to the command bar in Stata, then paste here, and there should be no space, and here we have AR1. AR1 is almost significant. It means with return on asset, our model is not facing problem of autocorrelation. With AR2, this is AR1, this is AR2 p-value, so it's almost significant, means 5%, very near to 5%. Okay, so this is all about the static panel and dynamic panel, and you can report the results in Excel like this. Then you can move these results into Word file and you can interpret the results. I will also upload a sample file of how we can report these results, how we can interpret these results. Then hopefully it will help you. And I'm planning to have a series of data analysis lecture series of data analysis dealing with primary data, secondary data, and advanced basic econometrics towards advanced econometrics. So hope I'll be able to find time, and hopefully this lecture will help you students to perform your analysis while you are keeping research project or you are going for writing the research paper. So it will help you help the early career researcher or the students who are conducting research first time dealing with the panel data or dealing with the descriptive stat correlation regression multicollinearity. I have explained what are the decision criteria, what will be the overall cutoff points and significance level and so on. I wish you best of luck. See you in next lecture.